For this project, we decided on working with reinforcement learning because it's a cutting edge in robotics research. We implemented the Q-learning algorithm. The idea behind the Q-learning algorithm is that for every state in our environment, we want to be able to predict the expected outcome of each action. We can call this the quality of the action. These values can be represented in a table, where each row will represent a different state, and each column will represent the possible actions at that specific state. Once we have learned these values, a Q-learning AI will simply pick the maximum quality action for whatever state it's in. The first game that we tested our algorithm on was the taxi game. The idea behind the taxi game is that the driver is tasked with reaching a passenger who is possibly waiting in one of the 4 pickup locations. Picking up the passenger and dropping off the passenger is the main goal of the game. There are 4 possible destinations and 4 possible pickup locations. There is no case where the pickup and the destination are going to be the same. The taxi must pick up the passenger and drop them off at exactly their desired destination to achieve maximum score in this simulation. The next game that we tested our algorithm against is Frozen Lake 4x4. The goal of the game is for the user to reach his frisbee location without falling into the frozen lake. There are 16 possible states, 1 for each position on the board, and 4 actions that the user could take, going up, down, left, and right. What makes this game interesting is that there is only a 1/3 chance of the agent's action being executed correctly. There is a 2/3 chance of the agent drifting off to either side. As a result, there is a lot of unpredictability in where you will end up.